So let's talk about some properties of the dot product. If we have any three vectors u, v, and w and any scalar c, that scalar can be zero, it doesn't matter, then we have the following five properties. One is that u dot v is equivalent to v dot u. So what that tells me is order doesn't matter. It doesn't matter which one you put first when taking the dot product. The second one is that u dot v plus w is equal to u dot v plus u dot w. So what that tells me is you could either add these vectors together and then take that dot product, which might be more convenient, or you could take the dot product separately. And we'll see reasons as we go along in this course why you might want to do something like that. What we also see is that if scalar multiplied times a dot product, you can either scale the first vector and multiply by or dot it with the second, or you can dot the first vector with the scaled version of the second. But more than likely, what you're actually wanting to do is to take that scalar out, do the dot product, and then multiply by the scalar. Fourth, we see that the zero vector dotted with any vector v is zero. And if you think about it, that makes sense because that's zero multiplied by each component. And then finally, we have that a vector, if you dot it with itself, you get the magnitude squared, which if you think about it makes sense because the first piece would be the first component multiplied by itself, the second component multiplied by itself, third component, so you'd have squared, squared, squared. So you'd have what you normally get with the magnitude except without the square root. So that has a kind of a follow through here, which says that if v is a unit vector, then v dotted with itself will be 1. Because the magnitude is 1, so the magnitude squared is also 1. This is a really convenient way to determine if you have a unit vector. So instead of having to do all the multiplications and take the square root, which doesn't take that much more anyway, if you take a vector and dot it with itself and you get 1, you know it's a unit vector. That's really helpful when you're dealing with things like in computers and stuff. If you do any kind of programming, you can save yourself a computation of a square root, which is kind of expensive from a computer standpoint. Anyway, these are the properties of the dot product.